Okay, my friends, another day in just crazy land. Are the cosmic voids truly empty? Well, what is a cosmic void? It means there's something in space. There's absolutely nothing there. It's impossible, and I'll tell you exactly why. Okay, here's why there is no cosmic void. This is what light particles are made out of, are dipoles. Light saturates the universe. Wouldn't you agree with that? Light goes everywhere. If it leaves something, it goes until it hits something. This is what light is made of. White electron neutrino and a dark muon neutrino attached together. They call them gluons. When they leave as light, they are known as photons. That is mass. That's a particle. There's no possible way that there's anything that's empty anywhere. You're at least going to have the particles of light flowing through there. Okay, my friends, dipole electron flood theory has been accepted by all the top physicists in the world that I know of, and it is light particles. They're not nothing waves of nothingness. They are particles that have dark matter, which is the black, and they have the white, which is the energy. Together in a box like that, two dipoles together, it makes up a photon. We were able to split these and split the black from the white. The black is the muon neutrino, and the white is the electron neutrino. The white went into showers exactly as they predicted, and the black stays on its own exactly as predicted. Light is accelerated, totally unpredicted. We can accelerate light, we can slow down light. Light's made of particles. There is nothing in the universe that is empty. It will, at minimum, it will have these particles flowing through there, or just laying around out there. These will become what's called the cosmic microwave background, which means particles that are just barely moving around out there. Light slows down. That is an absolute certainty. And the universe is saturated with light, and as other light hits other light, it slows down. Let me tell you something people don't know about light. Light is nothing more than sound. Light is just fast sound. Radio waves, sound waves, whatever, way down this end, scratching, all the way up to moving very, very fast in those frequencies until you get up way into the ultraviolet X-rays, gamma rays. It's just going faster and faster and faster. And we have proven this with our light experiments. Laser light is just another form of light. It's just coherent. Okay, what do you see here? You see dark regions, yes, absolutely. You see bright regions, absolutely. You see regions that are in between, and you see huge amount of interference to light that would be going through there. But there is no completely void spots there. It just can't possibly be. This light coming out of here, it's got to go through there to get to here. Now, maybe it bumps into there, but is that, and it might stop it. I can't say that's not true, because you shine light on a wall and it stops it. Is there any walls out there? I don't think so. I think everything, even if it was dark matter, it really has all the mass, basically. This has all the energy, the white part, this has all the mass. I show it to you right now in an atomic bomb blast. It's very, very, very easy to see. The white carries all the energy and burns things. The black carries all the mass and knocks things over. All right, this is what's not been understood. These particles are dipoles. They're just little tiny bar magnets. And it takes about 1840 or so to create the nucleus of the smallest particle, which is hydrogen. And that gives you one proton, basically. All the dark part of the dipole goes to the center, surrounded by all the white part. When you turn on an atomic bomb, It's so dense with matter. The dark matter is in the center, just huge amounts, just coated by scads of these white particles. And then you implode it inside, and then when it bounces back out, the white goes out first, and then the black follows it. I am going to show you proof. Okay, this is atomcentral.com. This is the Teapot Apple II Q House atomic bomb effects. They're testing atomic bomb during World War II in that era. Now, here's what's going to happen. They're going to set off the atomic bomb, which is a huge ball of mass. They go like this, and out it goes, and all the glowy parts go out first, the burners. All right, as I showed you in dipole electron flood theory, these are the ones that are going to go off first. They have all the energy. These are dark matter. These are actually dark matter and just nothing but mass. So the first thing that's going to happen, we're going to see the house burn up, and then we're going to see it get exploded into a million pieces. And here it comes. All right, this is Atom Central. Boom, the atomic bomb goes off. Now what did we see? Just nothing but glowiness. I stopped it, and everything is just smoking up. It's not moving. You see the poles smoking, the wires smoking. They're not going pushing this way. This is a bomb, atomic bomb. And the reason all that stuff is glowing is these are the things that are hitting it. And then next will come the dark matter that's in the center. All right, and it's massive. It's got all the mass. This has no mass. If it had mass, you would see those particles, everything would be moving that way. It has no mass. No mass. Here it goes. Just smoking. All of the roof, the shingles, everything will burn up, and then all of a sudden the house will go flying. See, whoops, here it goes. Bang. See you later, alligator. You know, they're getting close. They're starting to get close. The cosmic voids, are they truly empty? No, they're not. There isn't such a thing as an empty place. They say if we take out all the matter, the neutrinos, the dark matter, the cosmic rays, the radiation from the deepest parts of the voids, the only thing left is empty space. Well, how are you going to get all that stuff out of there? That's a silly question. I know it sounds like a paradox, but the voids are full of the vacuum of space-time. What the hell does that mean? And crucially, that's not nothing. Well, I say that's nothing. Forget about that, because it is nothing. Now, here we come to something that is something. It says, because the vacuum of space-time has something inside of it. Yes, it has the light particles. It has all these particles. You can't see them. They're dipole electrons. So they say it has something inside of it, or on top of it, or within it, or kind of existing within its fundamental framework. Look, it's kind of hard to precisely describe within words what's going on, but I'm talking about quantum fields. Quantum fields exist because of particles. You have to have the particle to have the field. In quantum field theory, the particles that make up our existence, like electrons and top quarks and neutrinos, and even dark matter, aren't really particles. Yes, they are. There's the mistake. You see this? I told CERN, University of Geneva, Fermilab, Lawrence Livermore, I told them all that we could see light with smartphones 10 years ago. Now they're transforming smartphone sensors into an antimatter collector to see antimatter. There is no antimatter. Okay, I think our leaders should see this, because this goes long back. This is 2013. Don Lincoln from Fermilab put out this saying this had all the energy, this had all the mass, smallest particles they can find. Okay, this is interesting because this goes back to 2013. And these are the particles Don Lincoln found or reported on at Fermilab. All the energy, all the mass. And there's the smallest particles they could find. We found them in our light experiments, the exact same particles. That's the particles I just showed you, and this was right from Fermilab. These are the particles we saw with CMOS, which is smartphones, a regular smartphone. That's what killed them. And I said to Don Lincoln, I said, we're doing this and we're accelerating the light, and we're, which we were, and we were creating these particles and seeing them and all, and the same particles they were seeing. Could we engage? And he was abusive, in my opinion, and would not engage. And I am blocked from being able to discuss anything with him. So when I saw, but first of all, this is what it is. These are the particles. The dark one has a glowy edge around it, which is exactly what he claims. The dark one has a glowy edge around, yes, because it's dark matter. It has to obscure light in order to be seen. You can't see that until it gets on top of light, so you see the light coming around it. We have the exact same situation right here. We see the light coming around it. You can't see the dark matter unless light won't get you'll see a black spot in the middle. It's dark matter, but only if you can separate it from the white. And we did by putting it through a Venturi. And we accelerated the light. It was quite obvious. And we found the particles that they were looking for. Now, I thought it was kind of nasty the way he treated me. So nothing ever happened for like 8 years. And then all of a sudden I see they got a new director there. So I emailed him. Okay, so I saw from Fermilab they had a new director. This goes back to 2022. Like I say, Don Lincoln, he was nasty. And I ended up going to University of Geneva for particle physics and showing them we use CMOS to see these particles. And they ended up using CMOS at CERN. They're doing it now. They're upgrading to using smartphones. I'm not kidding you. So I said, I saw your page on a new director, and then this was to Fermilab, SpencerStewart.com. Well, anyway, director search and experiment showing muons. All right, so I showed them the same stuff that they were. Here's Fermilab stuff. Here's our stuff. I showed them the whole thing. I said, I have information. Please acknowledge receipt. Thank you. I don't think I ever got acknowledged anything. And then I added some more stuff down here. And to not acknowledge that, to not say, to not have one question, and I hadn't had one question ever from a physicist about this work, not one, not a single one. So I thought I could maybe make contact with somebody. That's another 3 years ago. And they're still in, it's a turmoil there. They should take the money out of there and just say, you guys you failed. And this is my opinion. I would say take the money out. You're just wasting our money in buckets. And I started to look up what's going on there now. Hold on a second. See, new director of Fermilab. They're still looking for a new director. I think they must know how wrong they are. They have to, because I beat this thing like I beat it to death. And here's Fermilab undergoes leadership changes. Over and over, it's a leadership change. Now, this is just 4 days ago. And this is Don Lincoln. Well, I got me a new boss. Well, that was 9 months ago. Don Lincoln, I'm blocked. I can't get to his Facebook page. If I try to hook up with Don, sorry, you're blocked because I don't want to hear what you have to say, Roger, because you're going to make me look like a fool. I didn't want to make him look like a fool. I wanted to work with him, not against him. And he's working, in my opinion, against science and against the people of the United States and abusing his authorities there. He should have said, well, we should look into this. That's my opinion. Now they're using smartphone sensors looking for antimatter. There's no antimatter. There is no antimatter. This is an Aegis collaboration led by a team from the Technical University of Munich has repurposed smartphone cameras. You don't have to repurpose them, you just use them to create a detector capable of imaging anti-proton annihilations in real time with unprecedented resolution. Well, what's an anti-proton annihilation? It's a particle collision. You see this? antiproton. Now that's the key, proton annihilation, the process where an antiproton and a particle like a proton or nucleus collide, causing both to be destroyed and their mass energy converted into a burst of other subatomic particles such as pions and photons. They're hitting huge things like this. They're hitting huge bombs like this together, and they're shooting off all the little particles. Yes, photons. You see what antiproton annihilation is? All it is hitting the photons together. I mean protons and neutrons and smashing them to bits. They call them antiprotons. No, they're taking two particles like this. But instead of just being one big particle, it's 1,840 dipole electrons. Each one of these is a little magnet. You see that? And each one of those, together at 1,840 approximately, they become a pretty stable proton, which is the nucleus of hydrogen. It's the smallest particle. All right, it's right here. But it's not one. They would call it one. It's not one, it's 1,840. So when they smash these things together, they just get tons of particles. It's exactly what they say. Antiproton annihilation is where the particles like a proton or a nucleus collide, causing both to be destroyed and their mass energy converted into a burst of other subatomic particles. Yes, into dipole electrons. They no longer are held together. There's no stability once you get smaller than 1,840. They become unstable and they just burst into particles. The subatomic particles like photons. Absolutely, that's correct. You see this? This is exactly what we did. And we did it over 10 years ago. We did it with a regular smartphone. And it's the smartphone camera sensor. It creates a detector capable of imaging antiproton annihilations in real time with unprecedented resolution. Antiproton means just smashing it to bits. We created particle disintegration of photons. That's a magnitude of level way above that. All right, all they did was started to use smartphones the same way we did to watch this happen, because you can actually see it happening. They're right. Unprecedented resolution. They're taking these huge things and just creating just a ton of these particles into subatomic particles. Sub means smaller than atomic, yes. Some of them are gigantic jobbers, some of them are little bitty particles, some of them are 3 or 4 or 5 together, whatever they are, but they're just debris. We started with light, so we started 1,000 times smaller than that, and 1,000 times smaller. And we forced them to crush their fields, making the particles actually separate, the black and the white. All right, here's what I want you to think about. When these particles hit together, there's fields in between them, and that's correct. That's exactly right. There's a big fluffy field in between them. Ooh! And when you bring two magnets together, and in a non-attractive way, you'll feel like you're hitting a wall. If you have it turn it around, it snaps in solid as a rock. But if you turn it backwards, it's just like you're hitting a wall. And that's what this is the wall. All right, what we did was we forced them into each other's walls, and there's no way for them to get out. It's called a venturi. So what we did was we took the venturi here, right there, and a venturi accelerates what's coming into it. It's totally understood. See, nothing more basically than a nozzle on a hose. You come in and the water just goes blah, 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 comes out. You put the nozzle on there, you tune it correctly, you go 30 feet. That's what we're doing right here. It's this exact same thing. However, in photons, which are these right here, that's a photon. you have the black and the white. The black stays back, the white goes. It's a separation of powers, basically. This one goes, and the black stays back. And we can see it right here. There is no question that's happening. The black does not get through. The white squirts. Now, the black instantly comes back to the white when they get out to the other side of the Venturi. There's a threshold, pow, and they all jump back. And they create Higgs fields, another big thing that they were all impressed about is these Higgs fields. All they had to do was use the CMOS. But the problem is they were using these huge particles. So the CMOS was getting damaged. Remember I showed you this? They're throwing out chunks that could be this big. It's called an X. It could be any size. It's just anything. However, we started with this, so we're never going to be any bigger than that, so we can't damage the CMOS. They could hit it with this, and the cell phone's destroyed. And that's what they told me. You can't do that because of high energy particles. And I said to Don Lincoln, I said, no, we're using photons, so we don't have those high energy chunks. And he was, again, he was abusive, that's my feeling. And he certainly wasn't asked, he never asked one question about anything. He just said, oh, you're just seeing interference patterns. And I said, no, these aren't. I just said, well, anyway, it was a real drag out. And finally, I told him, I said, at some point you should be held accountable to the people of the United States for what you're doing. And he blocked me. And I still feel that same way, and that's my opinion, and I think that should be handled in a legal way. Anyway, we can see what we see. And these are the particles they want to see, but they won't look. They won't look. And it's telling me that light comes through there and it never slows down. That's absolute. Well, let me put it this way, it's a little hard to believe. Here's blue coming through, slowing down. Look at it. You see how fast and tight it is? And light spins just like that. The particle's at the end, and it spins just like that, just like this. And it's spinning so fast, you can't, it's taking shots stacked and layered. And what we're seeing is a whole line of that same shot instantly. Now here's another coming through. I'm not going to just go, because this is a little tricky. But this is the black stuff, and here's the white stuff in front of it, just like the house I showed you burning up. Burn, 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 when the black hit. So this allows a little of each. I got a lot of information on this, and the things that all you got to do is use a cell phone to see this stuff. I don't know what it is, and nobody can tell me what it is. Nobody knows what it is, but I can tell you what, everything is basically dipole. You got black and white, black and white, black and white, black and white, and then you got all these fields. Those are push-to-shove fields. And they're real tight, and then they get slow. That's light, basically, or it's the emanation of energy slowing down. That's all it is. And light slows down. It's not the universe is just going wild. And what they're looking for is this, and they say, wow, now we can see it in unprecedented. I haven't seen them show anything, but this is what they're going to see. Big deal. All you're seeing is a bunch of these things going flying everywhere. We're seeing what really matters is the light particles themselves. We got these in green and blue and red, and we can see here's the green ones. Same thing. We're being misled. I'm telling you right now, we are being misled. And this is like before it really accelerates. It's just starting to accelerate now. That's the only reason we can even see it. All of these particles in the air are being accelerated a little bit because all their fields are sort of pushing together like a big mush of this stuff. And it could be that something's coming through here, mushing, causing these I don't know what's going on in this, but this is outer space. This is right in our neighborhood. And I got a guy with a Newtonian, 5-inch Newtonian telescope, got all kind of bells and whistles, and he's doing some fabulous stuff. And we're trying to figure out what we see. But this is the cell phone we use, the Samsung Galaxy S3. It went back to 2012. This is the one of those shots that they'll never figure this out. What happened here was the Higgs fields, as they came back together, crushed one of these. They're all red when they start. It crushed and it squirted out like a toothpaste tube. It crushed it into blue. You see it? I've never seen another one like that, to be perfectly honest. Well, I've seen a couple that are close. And here's the red, gaining energy, and then all of a sudden showing up as a photon. And then here, it goes into crazy land, and everything falls apart. And again, there is nothing, there's no voids in space. Empty space isn't empty. That's the one thing Don Lincoln said that I agree with. And this again, 2013. And it was very discouraging, you know, having somebody that's funded by me and you and everybody else refuse to engage. And in my opinion, I can't imagine somebody being as incompetent as to miss this. As to say, oh no, Roger, you're wrong. That's not the same thing. You're just seeing some silly stuff. Well, he called me a tinfoil hat guy and an embarrassment to science. So he just didn't care. In my opinion, that's my opinion. So until we get somebody there at Fermilab, I would ask Trump to just shut the damn place down. It's just a waste of money, huge waste of money. And I have other things that I'd like to talk to him about too. I've found very discouraging when it comes to science in the US of A. All right, we should make science great again. Massaja. Okay, give them full credit for this. They did have to re-engineer the CMOS and change some of the, you know, the blocking from hitting the CMOS and damaging it. Whatever they did something. But I'll give them that. But here's the deal. They say the extraordinary resolution enables us to distinguish between different annihilation fragments. So they can see a chunk like this or a chunk like that. Big deal. What does that do for you? What I'm giving you is the particles. We can see the actual Higgs fields. Every one of these is a photon reassembling. This is the white part coming through the Venturi. And somewhere here it is, these black particles are everywhere because they immediately turn into these Higgs fields. And I think this is one here you can sort of see. You see the white and the black and the white and the black, and then it just turns into a field. Some of these, it's hard to make out what they're doing. All right, but this is how light spins. I told you it screws just like that. Round, around, 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 around. And it does cause these interference patterns, but they're not flappy waves spreading out like this and that. It's a spinning particle. All right, so this particle's going here. Sometimes they go this way, sometimes they go this way, but the bulk of them go through the center. But once they get on the other side, they stay away from me, you stay away from me, I'll stay away from you. And they make these interference patterns. They're actually repulsion patterns. Every white particle that gets through on the other side says, you stay away from me. You got too much energy to come close to me. So they create an exact perfect line, straight down the line. You see that? That's the red and the green at the same time. Green, very powerful compared to the red. The red is just pushed out of the way and tumbles. They don't tumble. They always go like this, upspin or downspin. They're always like that, except in this case because it tumbled because of pushing its field away. This We could get into some antiparticles here. Yes, possibly. I think I have figured out what this is after 3.5 years working on it. I believe I do know what that is. And I'll explain it to somebody from CERN or wherever if they would like. Now, all of this stuff, what I'm showing you, is just factual. It's just what they see. These are particles they see. We see them too. And we separated them. That's fission. When you separate the particles and the black comes away from the white, that's fission. Come back together, it's fusion. We accelerated light. We split light. We created a subatomic nuclear explosion right there. Anybody want to argue with that? Let's discuss it. That's a subatomic, smaller than atoms, nuclear, because that's where the nucleuses are, explosion. Who will argue that? And if no one will, I win. I get these every day now. What if Einstein was only half right? NASA's new test for dark energy. They have no idea what they're looking for. They have no idea what even they're looking for. New strategies may soon allow scientists to test dark energy theories within our own solar system, linking cosmic scale physics to local observations. Well, I got local observations I'd like to have linked to cosmic interactions, yes. Because I can tell you, the more you get of these particles together, the black and the white, well, here, hold on, let's go to the real dipole electron flood theory. The more you get of these particles together, the harder the white ones will try to attract to the black. That's what energy and electricity is. When you can keep the white away from the black and then run it through a wire or whatever, it will go through a wire, it'll make engines turn, it'll burn you right up to get to that black. White wants to be attached to the black. That is the strong, strong, strong nuclear force. This one right here, the gluons. Now, the bigger it gets, the harder it sucks. You get, that's what a whole atomic bomb is about. It's bigger and bigger and bigger and bigger and bigger, and more and more and more and more. And then you implode it in, and when it goes out, is when we saw all the white stuff burn up the house, and then the black stuff came behind and smashed it. This is the mass. We are standing on dark matter right now. You and I are made of mostly dark matter. You saw what happened when the brilliant white stuff, the electron neutrinos came and burnt the house up. Didn't move it. There's no matter there. You could stand on that and you just fall right to somewhere where there was matter, and it's going to have to be dark matter. Everything's made of dark matter. Dark matter is in space on its way to the Earth. All right? Dark matter is particles glued to the glowy particles. You don't see them in space because they're not hitting anything. They do not glow until you get push to shove, field against field. It's very, very simple. Every particle has a field surrounding it. So that's where the wave comes from. As the wave goes through, it creates a wave. As the field goes through, it creates a wave. The particle's in the center of that wave. And I showed you that wave is right here, somewhere. Here it is right here. It's just starting to accelerate. The particle's in here somewhere. But it has a big field around it. So in order to get through there, it says, yeah, get out of the way, get out of the way. And they say, oh yeah, and they push and shove, and you get the little glow of everybody else trying to get adjusted. And this guy just says, get out of the way, and it keeps going. Now, we made it accelerate so it went like a rocket ship. Pulled itself right out of its own wave. And at the same time, every particle in here is glowing like crazy. And these fields, these are photons. You don't see them. They're coming here. They're coming right along. They're all over the place. And I'll show you how many there are. And the only reason you're seeing these is because they're being pushed backwards. That's why they're glowing. The field is pushing backwards at them, and then you get this intense glow back there. All of those reverse electromotive force, pops. This is serious. This is a very, very serious reaction. And this is what it would look like if we could see in here and all in here. The only reason this one's accelerating is because it's heading dead for the Venturi. This is what they look like coming through. Now, you see this is glowy. There's a batch of them sort of interfering with each other. That's why they're glowing. Here, that one there is trailing off. You wouldn't see it in a second. It's nobody's saying, you get, no. So empty sort of space. It's still there, but it's not glowing. All right, and now I showed you the red ones coming in, and then right about here, it pops into the photons because it thinks it hit a wall right there. They don't turn into photons until they hit something. And it hit the reverse concussion, which is quite obvious how these are being concussed backwards. You see all the white particles? Everything in here coming back is hitting it, making them glow like crazy. I think I made my case. And empty space is not empty. There's no such thing as voids and so forth like they're talking about. And all they're able to do now with these cell phones is see the explosion and really, see it perfect as we see all the particles we're showing. We don't need a Big Bang theory. The Big Bang theory is nonsense, basically. As far as it's nothing is expanding, I don't think. There may be some expansion, I don't know. But that's not what's stretching the light. They're talking about it's sucking the light this way, that's why it's shifting red. No, it's going slower because it's coming through this goop. That is going to slow it down. I don't care what anybody says. No way in the world is that light going to continue on at the same speed. I have shown Einstein's completely wrong. Light can accelerate. We knew it could slow down going through a different media, yeah, but you can't accelerate it. However, yes, we did accelerate it. So, Mr. Einstein, if you were only half wrong, well, that would be good. But I think you got a lot of issues, my friend. And I would like to discuss that with Mr. Einstein. Unfortunately, he is no longer with us, but his theories and so forth are. And there's a lot of stuff. He was in a place where nobody knew anything. And they still didn't know anything until Rod Warren and I started with this. Rod showed some pictures, and I said, how did you get these pictures? And he helped me, and we both learned how to do this. And 90% of this is Rod's work. And just fabulous, fabulous, stunning, stunning stuff. And this goes back to 2012, 2013, right in that area. And again, I sent it to everybody. And I ended up deciding, well, I'll take a course at the University of Geneva, and I'll make them listen to me. And they did. And guess what? Now they're upgrading to CMOS. All right, I guess I'll leave it at this. There is no voids in space, first of all. We know that. And now CERN is using smartphones. April 2025, they're talking about using the smartphone cameras for unprecedented resolution of these explosive events. Well, we don't have to have an explosive event, proton to proton, smashing to bits. All you're doing is looking at a whole batch of debris being created. We're actually looking at the photons, and the photons breaking apart and turning into dipole electrons, photons, electron neutrinos, muon neutrinos, and here they are, right here. This is exactly what they call them. Muon neutrino turns a black ball, right there. And it's dark matter, they didn't realize. Electron neutrino is the electron shower, and there it is. And we did this with the smartphone over 10 years ago. All right, thank you. I love you all. And don't forget, things are much different than we've been told. And just to continue saying what they tell you to say, this is not the way to do business. Science has been very, very degraded due to this peer review nonsense. They refuse to speak. And all they have to do is just never respond. Or block you like Don Lincoln blocked me. And I know, you know, it's a way of doing business now in the scientific community. That's my opinion, and you're going to have a hard time convincing me of anything different. And I guarantee you, or I can't guarantee it, but I will be very, very surprised if there's any talk about the things that I presented by anybody that's in a position to make claims from any of these laboratory places, Fermilab, CERN, Lawrence Livermore, anywhere. I don't care where they're from. They're just not going to do it because they can't. They can't stand up to my evidence. And in order to stand up to my evidence, they have to agree dipole electron flood theory is quite obviously the way it works. And this changes everything. It changes every single thing. Because in between every one of these, there's thousands and thousands and thousands of isotopes. And isotopes aren't just extra protons and neutrons. They're extra dipole electrons. So if they say it added one extra neutron, no, it added 1,840 dipole electrons, because that's what makes up a neutron. And not, so when you're starting to get into half-lives and all that stuff, and how nucleophilic substitution and nucleosynthesis works, they're lost. I'm telling you, it's unbelievable how lost the scientists are now. And it's because they have to say what everybody else told them to say, or they just get pushed off to the side. It's not the way to do business. All right, love you all. Bye.